Alright, so we'll look at an example for the binomial theorem. Let's look at the example of x plus 2 raised to the 8th power. Now obviously that power could be written as x plus 2 times x plus 2 times. Now I'm not going to write this all actually the 8 times, but you get what I'm saying. You have to write 8 of these out 8 times, right? And then you have to use the distributive property over and over and over and over and over again. Well, that seems like a lot of work, and it is. And if you're a math geek like me, you might enjoy that. Most people want to find shortcuts to things like that. And so there is a cool shortcut, and we just talked about it in the binomial theorem. In order to use that shortcut, what you need to do is first find the row of the Pascal triangle that has an 8 as the second number. So we'll just start by building out a Pascal triangle. Yeah, let's do that right here. 1, 1, 1. 1, 2, 1. Again, the Pascal triangle, you're adding the two numbers above to get the next number. So 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So that's the fifth power. This would be the sixth power is 1, 6, 15, 20, 15, 6, and 1. Let's see, I need a couple more rows yet. 1, 7, 21, 35, 35. There is some nice symmetry. Once you get one half of it done, you can zip through the other half. Now finally, this is the row we're looking for. 1, 8, 28, what's that, 56? And 70 and 56, 28, 8, and 1. So I have my coefficients now. Alright? So I'm going to write these out. Now remember what I said in the last video, that these are the coefficients, but then you take each term and you use different powers that need to add up to 8 for each term. They decrease with the x and increase with the 2. Alright, so let's run through that. Let's look at the coefficient of 1. That first term is going to be 1x to the 8th. Right? Every term has to have the powers add up to 8. Then you have 8x to the 7th, and then a 2. Right, times 2. That 2 is really to the 1 power. So what we're going to start doing is we're going to start decreasing the x's by a power and increasing the 2's by a power. Okay. So then we get 28 x to the 6th times 2 squared. And then you get 56 x to the 5th times 2 to the 3rd. Right, noticing that the powers always add up to 8. Then you get 70 x to the 6th. No, I got to decrease that one, right? That's x to the 4th times 2 to the 4th also. They got to add up to 8. We'll start down here. That's going to be a 56 x to the 3rd times 2 to the 5th. 28x to the, let's see, 3 becomes 2, and 2 to the 5th becomes 2 to the, add 1 would be 6. And then you go with an 8 for the next coefficient. That's 8x times 2 to the 7th. And then the final coefficient is 1, and then you get 2 to the 8th. Okay. Now that's long, but it's still way faster than doing this multiplication 8 times. Now I do need to simplify a few things just to tidy up those coefficients. So I've got my 8x, I got my x to the 8th. Then I've got 8 times 2, which is 16, so that ends up being 16x to the 7th. This is 4 times 28. I'm going to run through these on the calculator off to the side here. That is 112 x to the 6th. Then we got 56 times 2 to the 3rd. 2 to the 3rd is 8. So it's 8 times 56, which is 448. So I got 448 x to the 5th. We got 70 times 2 to the 4th is 16. So 70 times 16 is 1,120. And that'll be times x to the 4th. Then 56 times 2 to the 5th is 32. So 56 times 32 is 1,792 times x cubed. Then you get 28 times 2 to the 6th. 2 to the 6th is 64. So that'd be 28 times 64, which is... That's interesting. Did I do something wrong? 2 to the 8th. No, 2 to the 6th is 64. Just making sure, because I got the exact same number there. So that's 1792 x to the 2nd. And then you get 2 to the 7th, which is 128 times 8. That's 1024. 1024x. And then finally 2 to the 8th, which is 256. Okay. Ooh, just squeezed that on. I wasn't looking at the camera. Just squeeze that in there, huh? Okay. And there's no simplifying once you've done that. I mean, once you've got your coefficients figured out, I've got my decreasing x values all the way down to 0. And that pretty much does it. So you take, once again, I'll rehash this. You look for the row, you build up the Pascal triangle until you find the row that has an 8 in the second spot. Then you use that row as the original coefficients. Then you take the two terms here in the binomial. The first term, you start with the max power there of 8 and decrease it by 1 all the way down. The other term, the second term, you start at 0 and increase it to 8. So here there's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, up to 2 to the 8th. When you multiply all that stuff together in each term, you just get a really big polynomial. And it has a degree of 8, which is what we should have because the original polynomial had a degree of 8.